Chapter 6.1, Inverse Circular Functions. Inverse functions, okay? So this first part that we're going to talk about should be a review from college algebra. So first off, for a function f, so for it to be a function, every element x in the domain corresponds to one and only one element y, okay, in the range. So that means if there's a point A, B on the graph, then there's no other point that has A as its first coordinate. Other points may have B as a second coordinate, however, because the definition of a function allows range elements to be used more than once. So what that really means is that, say this is AB, there cannot be another point here, A, we'll call it C, okay, because then it wouldn't pass the vertical line test. However, there can be another point here that could have the same y value, and we'll just call this D, dB, okay? So it can have the same y value as AB, as B, but not the same x value, okay? If a function is defined so that each range element is used only once, then it is one-to-one function. The horizontal line test helps determine graphically whether a function is one-to-one. So the horizontal line test is a function is one-to-one if every horizontal line intersects the graph of the function at most once. Okay. So examples from college algebra. Say we had a quadratic function, okay? It is a function because it passes the vertical line test. However, it is not a one-to-one function because if I draw a horizontal line, I intersect 2 points, okay? So this is not one-to-one. Another example from college algebra would be, so this is x squared. This is an x cubed function, which looks something like this. And anywhere that I do draw a horizontal line, I only hit one time. Okay, so this one is a one-to-one function. Inverse function. Okay, the inverse function of the one-to-one function is defined as follows. Okay. So the point becomes yx for every xy that belongs to f. So that's just saying that if we had this graph, if we have a point here, AB, then the point on the inverse function would be BA. Okay, so you just swap the x and y values. Do not confuse the -1 in f inverse with a negative exponent, okay? So that -1 represents the inverse of the function, read f inverse, okay? It is not 1 over f of x, so make sure that you are aware of that. Summary of inverse functions, and I'll go through a step here. So to solve it, so in a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. If a function is one-to-one, then the function has an inverse function. Okay? The domain of your function is the range of your inverse. And the range of your function is the domain of your inverse. Okay? That's because we're swapping x and y values. So all the x values of your function become the y values of your inverse. The graphs of f and f inverse are reflections of each other over the line y equals x. And then to find f inverse, you're going to go through these steps. Step 1, replace f of x with y and interchange x and y. Step 2, solve for y. And then step 3, replace y with f inverse of x. So if we were doing an example from algebra, we could say our function f of x equals x cubed. Okay, so we just talked about that x cubed is a one-to-one function, so therefore it does have an inverse. Okay, so first we're going to replace f of x with y, so y equals x cubed. Then we're going to swap x and y. So then we're going to have x equals y cubed. Okay, and then you want to solve for y. So we're going to do the cubed root of x equals y. And then replace y with f inverse. So f inverse of x equals the cube root of x. Okay, so this would be the inverse function for function x cubed. Alright, so that is a review on inverse functions. That is strictly from college algebra. So let's talk about an inverse sine function. Okay, so an inverse sine function, so it's either written y equals sine inverse of x or y equals arc sine x. Okay, so this both means that x equals sine y. So the x and y are swapped just like they would be if you were dealing with a quadratic or cubic. Okay, notice here that y is between negative pi over 2 and pi over 2. Okay, so if we were to look at a sine function, okay, so remember, for it to have an inverse, it has to pass the horizontal line test. Okay, and because sine repeats itself, we have to cut it into an interval in order to have a one-to-one function. Okay, so sine is 1 to 1 in between negative pi over 2 and pi over 2. Okay, any other, so if we went to 0 to pi, then we wouldn't pass that horizontal line test. So we have to go from negative pi over 2 to pi over 2. So we'll say sine looks something like that. So negative pi over 2, and this is pi over 2. So the only part that we are looking at is from here to there. Okay, so that is 1 to 1. We can think of y equals sine inverse of x or y equals arc sine x as y is the number or angle in the interval negative pi over 2 to pi over 2 whose sine is x. Okay, the domain of y equals sine inverse x is negative 1 to 1. Okay. So remember, the domain and range swap from your function, and this comes from the range of our sine function is negative 1 to 1. Okay, so that is the domain of the inverse function. Now here, the range of our inverse sine function is negative pi over 2 to pi over 2, because this is what we restricted our domain of our sine function to be. Okay, so when we swap domain and range from our sine function, our range is now negative pi over 2 to pi over 2. Alright, so example 1, find the value of each real number y if it exists. Okay, so for A, we have y equals arc sine of square root of 3 over 2. Okay, so y is our angle, and square root of 3 over 2 is positive. Okay, so since we're talking about sine, this is going to be in quadrant 1. Okay, and the reason it is in quadrant 1, so let me go back a step. So recall that y, negative pi over 2, y is between negative pi over 2 and pi over 2. Okay, so if we were looking at a graph here, so 0, pi, this is pi over 2. Here we can call this is negative pi over 2. Okay, so if we were going to go down, that would become negative, and then up would be positive. Okay, so our sine inverse function is on quadrant 1 and quadrant 4. Okay, so this is the only part where our sine inverse function exists. Okay, so that means that if it is positive, it's quadrant 1, If it is negative, it's going to be in quadrant 4. Okay, because this is the only part, negative pi over 2 to pi over 2, where y exists. Okay. So because this is positive, we are in quadrant 1. Alright, so we are going to take the sine of both sides. So sine of y equals sine of arc sine square root of 3 over 2. Okay, so if you recall from college algebra, taking a function of your inverse is going to give you the x value. So this means that sine y equals square root of 3 over 2. Okay, and then if I were going to draw a graph, we're in the first quadrant. Okay, so sine is going to give me y over r. So this is r is 2, and then y is going to give me square root of 3. And then we know this is a 30, 60, 90. So this is 1. And then this angle right here is going to be 60 degrees. Okay, we were given our range of negative pi over 2 to pi over 2, which is in radians. So that means that our answer needs to be in radians. So 60 degrees is equal to pi over 3. Okay, so this means that y is equal to pi over 3. Alright, b, so we have y equals sine inverse of negative 1/2. Well, negative 1/2 is negative, so that means that we are working in quadrant 4. So I take sine of both sides. Sine of y equals sine of sine inverse of negative 1/2. So this gives me sine y equals negative 1/2. Okay, and we are in quadrant 4. So I have negative 1 here, and then positive 2. Okay, remember your radius is your hypotenuse or your radius is always positive. And this is going to be square root of 3. So this is the angle we're looking for. And from our 30, 60, 90, we know that this is a 30-degree angle. However, our angle is coming from the x down, so this is going to be negative 30 degrees. Okay, because we're in negative pi over 2, so this is negative pi over 2 to pi over 2. Okay, so in the fourth quadrant, you're going to have negative angles here. And again, we want to put our answer in radians because our interval was given in radians. So negative 30 degrees is equal to negative pi over 6. So that means y is equal to negative pi over 6. Okay, here, so we take sine of both sides. So we have sine y equals square root of 2. Okay. Square root of 2 is approximately 1.414. Okay, so that means that square root of 2 is greater than 1. Okay, recall that our domain here, so our domain of sine inverse has to be between negative 1 and 1. So square root of 2 is not in the domain. Okay, it is not in the domain of the inverse sine function. Okay, if you were going to draw this in your right triangle, so we would draw this in quadrant 1 since it's positive. So you would have y, which is square root of 2, and then 1 for r. Okay, so you'd also notice on a right triangle, r, your radius, should be the largest distance. Okay, however, it's not because square root of 2 is bigger than 1. Okay, so that's another way you would see that. Okay, so when you're working with these, make sure that the number given for an inverse function value is in the range of the particular inverse function being considered. So graph of the inverse sine function. Okay, so written as sine inverse or arc sine. So the values here in this table are opposite of what you have in your original sine function, okay, because the x and y values swap. So here, sine at 0 is -1, so that means here at -1, sine is 0 at 0. Okay, so that's going to be the same because they're both values are 0. At -1, sine is -pi/2. At pi/2, sine is 1. Okay, so that means at 1, inverse sine is pi/2. Okay, so the values are just swapping. Okay, at -square root of 2 over 2, we have -pi/4, and then square root of 2 over 2, we have a positive pi/4. Okay, so the x and y values have swapped from your sine function for inverse sine. So our domain is -1 to 1, and then our range is -pi/2 to pi/2. The inverse sine function is increasing on the open interval from -1 to 1. Okay, so it's increasing, and it's continuous on its entire domain. Okay, its x and y intercepts are both 0, 0, and its graph is symmetric with respect to the origin. Okay, so this function is an odd function. For all x in the domain, sine inverse of -x is equal to negative sine inverse of x.